Welcome in refrigeration and air conditioning lecture. Today we will see the vapor refrigeration system. Under this topic we will see the first method of vapor refrigeration system, that is vapor compression system. There are two vapor refrigeration systems. If we see the basic applications, then most of the applications are using two types of refrigeration system, that is vapor compression refrigeration system and vapor absorption refrigeration system. So in this lecture we will see the vapor refrigeration system, that is vapor compression refrigeration cycle. So in vapor compression refrigeration cycle, if you see the basic block diagram, so this is the typical single stage vapor compression refrigeration, in which there are four basic components. First one is compressor, second one is condenser, third one is expansion valve, and fourth one is your evaporator. If we see the basic working of vapor compression cycle, then low temperature, low pressure vapor refrigerant coming from the evaporator goes to the inlet of the compressor. In the compressor compresses this low pressure, low temperature refrigerant, and its temperature and pressure goes on increasing. So the vapor refrigerant's temperature and pressure increases, and this increased temperature and pressure of refrigerant goes to the condenser. In the condenser, it rejects heats, and the vapor refrigerant is converted into the liquid form. The condenser may be the air-cooled condenser or a water-cooled condenser. Then this liquid refrigerant goes to the expansion valve. So in the expansion valve, some amount of liquid is converted into the vapor form. So liquid and vapor refrigerant is coming out from the expansion valve, and its pressure is drastically reduced. So this liquid plus vapor refrigerant then goes to the evaporator, where we require the cooling effect. So this liquid refrigerant is totally converted into the vapor form. So this liquid plus vapor refrigerant, which is coming into the evaporator, is totally converted into the vapor form by taking heat from the space where we require the cooling effect. So here evaporator is located where we require the cooling effect. And while in case of condenser, we reject heats through air-cooled condenser or a water-cooled condenser. For small capacity refrigeration plant, we are generally using the air-cooled condenser. For large capacity refrigeration plants, we are using the water-cooled condenser. So this is the heat taking place where we require cooling effect, and this is the heat rejecting place through the condenser. So these are the four basic components, and the cycle is continuously working. So the refrigerant, we can use any type of refrigerant into the vapor compression cycle. It may be R134A, R12, R22. So this is the basic fundamental cycle of vapor compression cycle. So if you see, when you go for the analysis of any vapor compression cycle, then it is very necessary to use the different pH chart for the analysis of any vapor compression cycle for finding the COP of the system. So if you see the pH diagram, then this is your saturated liquid line, then critical point, then this is your saturated vapor line. So this region we generally called it as a subcooled liquid region. This region in between saturation liquid line and saturation vapor line, that is liquid plus gas mixture, and the region above this saturation vapor line, that is superheated gas. So if you see in pH chart, which is very important while go for the analysis of any vapor compression cycle, then this pH diagram, if you see, these are the isothermal lines of subcooled liquid. Here you can see that these are the temperature scale for saturated temperature. This is your saturation liquid line, this is your saturation vapor line. Then these are some isoentropy lines, isospecific volume lines. These are isothermal line for superheated gas, superheated region. So this pH diagram is very important. So we are using the different pH chart for different refrigerants in the analysis of vapor compression cycle. If you see the vapor compression cycle with the TS diagram, then this is the basic 4 components we are using in any vapor compression cycle, that is compressor, condenser, expansion device and the evaporator. So here you can see that in TS diagram, that is 1 to 2 is your compression process and 2 to 3 is your condensation process. It rejects it into the condenser. 3 to 4 is the expansion process, that is your 3 to 4 expansion, and 4 to 1 is your evaporation process in evaporator, where we require the cooling effect. Okay, so that is the 4 to 1 is your evaporator. And so here if you see the PV and TS diagram of vapor compression cycle, in that PV diagram you can see that these 4 processes are there. That is a compressor, so work in, that is a compressor work, then heat out into the condenser, that is condensation, throttling, and then evaporation, that is heat in evaporator. Okay. So this region you can see that is a subcooled region, then liquid plus vapor region, and that is a superheated region. So this is your typical TS diagram, in which we already studied these processes 1 to 2, 2 to 3, 3 to 4, 4 to 5 and 5 to 1. So here we are getting the refrigerating effect during the process 5 to 1. So in that vapor compression cycle, if you see the analysis, then the analysis of any vapor compression cycle is very important. That is based on your basic values of enthalpy, that is total heat content enthalpy we need to find out. So for finding this we require different charts of refrigerants for finding the enthalpies. So for different refrigerant, different pH charts we are using for finding the COP of the system. So when we go for finding the COP of the system, it is required to calculate the 2 parameters, that is refrigerating effect and the compressor work. So in refrigerating effect we are getting here in the evaporation process, and compressor work we can find out with the help of the work required to run the compressor. So output of this any refrigeration system in vapor compression cycle, here you can see that is refrigerating effect, while the input is nothing but the power required to run the compressor, that is the input required. So if you see the basic advantages of vapor compression cycle, then the size is very small. So you can say that compact size is there as compared to other refrigeration system. Then volume of refrigerant circulated is very low, hence running cost is low. So running cost is very less compared to other refrigeration system. High coefficient of performance, that is COP, is very high compared to others. Then operating temperature range is huge. The next advantage is the temperature at the evaporator can be easily controlled by regulating the expansion valve. That is one of the most important advantage you can say. Then latent heat involved in phase change ensures high value of heat removal, while in air refrigeration system has sensible heat only. So that is also one of the major advantage of vapor compression cycle. Then it requires smaller evaporator. The size of evaporator is less compared to the other refrigeration system. If you see the disadvantages of vapor compression cycle, then that is a high initial cost and a costly refrigerant. So initial cost is very high in case of vapor compression cycle, and also we are using the costly refrigerant. Then second disadvantage of this vapor compression cycle, that is environmental hazard refrigerant. Okay. And if you see the third disadvantage, we must ensure the prevention of leakage of refrigerant. So the leakage of refrigerant is the common problem in vapor compression cycle. We always ensure the prevention of leakage of refrigerant, as the cost of refrigerant is very high, and when we are using this refrigerant into the refrigeration system or in vapor compression cycle, then because of the high cost, we need to prevent the leakages from this vapor compression cycle. So in this lecture, we studied the basic fundamental working of vapor compression cycle, and in that working of vapor compression cycle, we also studied the analysis of this vapor compression cycle. With the help of pH diagram, we can go and then advantages and disadvantages of this vapor compression cycle also we studied. If you have any doubt related to this topic, then you can contact me on this given number. Thank you.